You know, it's one of those things we never really think about. How does the internet actually work? I mean, how does a signal from halfway across the world find your specific phone or laptop out of literally billions of other devices? It feels like magic, but it's all built on a system of addresses. And way back in the early days, that system was headed for a total catastrophic failure. Until a super simple but brilliant idea, basically inspired by slicing a pizza, came along and saved the whole thing. All right, let's really get into this with a question you've probably never asked. You hit play on Netflix. That movie data has to travel from some server maybe hundreds of miles away through this insane maze of cables and routers and land precisely on your screen. Not your neighbor's screen, not the phone in your pocket. Your laptop. How in the world does it know the way? Well, it all starts with a digital address. Think of it like this. All the data flying around the internet is like cars on a massive global road trip. And for any of those cars to get where they're going, they need a specific street address, right? Well, in the digital world, that address is called an IP address. It's the absolute fundamental coordinate for everything online. And this is the really important part. Every single device that's connected to a network, your laptop, your phone, your smart TV, heck, even your smart fridge, it has its own unique IP address. It's like a mailing address just for data. Without it, your device would be completely invisible, totally lost, and couldn't send or receive a thing. Now, there are two main flavors of these addresses. You got the classic IPv4, which is what we're going to focus on because its limitations are what caused our big crisis. And then you got IPv6, the new kid on the block. And just look at that thing. It's so long, people have called it a postcode from space because it gives us an almost unimaginable number of new addresses for the future. But before we get to that, we have to understand why the old system broke. Okay, so every device has an address. Simple enough, right? But there's another piece to this puzzle. Your computer also has to know, is the device I'm trying to send this to right here on my local network with me? Or is it way out there on the big wide internet? And this is where something called a subnet mask comes into play. The subnet mask is basically a bouncer at a club. It takes one look at a destination IP address, and it instantly knows if it's on the local guest list or not. The way it does this is by splitting the IP address into two parts. You have the network ID, think of that as the neighborhood, and the host ID, which is the specific house number on that street. It's a super quick way to sort local traffic from traffic that needs to go out to the internet. So we have addresses, and we have a way to tell if they're local or not. Sounds like a pretty solid system, doesn't it? Well, no. In the early days of the internet, the way these addresses were actually handed out was incredibly rigid and honestly, just plain wasteful. It was a ticking time bomb that nearly brought the internet's growth to a screeching halt. See, back in the day, the internet used this system called classful addressing. When you needed IP addresses, you didn't just get the number you needed, you were assigned a massive pre-sized block. You could get a Class C for a small network, a Class B for a medium one, or a Class A for a truly giant one. And that's it. There was no in-between. Now, just to give you an idea of the scale we're talking about, if you were an early company or university and you got assigned a Class A network, you were given a block with over 16 million potential addresses. 16 million! Just wrap your head around that for a second. And right here, this is where the whole problem just stares you in the face. Imagine you're that company. You've got 500 employees, so you need 500 IP addresses. But because of this rigid, classful system, you're forced to take a block of 16 million. That means you're just sitting on and wasting millions and millions of addresses that nobody else in the world can use. The result was totally inevitable. IP address exhaustion. We were burning through the limited supply of addresses at an absolutely insane rate. Not because there were too many devices yet, but because the system itself was unbelievably inefficient. The internet was literally running out of room to grow. The internet needed a hero. It needed a smarter, more flexible, more intelligent way to assign these addresses. And that hero came in the form of a new system, which we can understand perfectly with a really simple analogy: slicing up a pizza. Think about it. The old classful system was like a pizza place that only sold 3 sizes: small, medium, and large. If you were kind of hungry but not starving, well, too bad. You had to buy the large pizza and just throw most of it away. The new way, called CIDR, was like being handed a pizza cutter and being told, hey, take exactly the size of slice you actually need. Total game changer. So, this new system was called CIDR. It stands for Classless Inter-Domain Routing, which basically means it got rid of those rigid classes. Instead, it introduced this simple little slash notation. That number after the slash tells a router exactly how many bits of the address define the neighborhood, which in turn determines the precise size of that network. No more fixed sizes, no more wasted space.
So here's what that looks like in the real world. A /24 network is perfect for a typical home or small office, giving you about 254 addresses. Need fewer? Well, a /26 gives you 62, and a /30 gives you just 2, like a tiny 2-room flat, perfect for a direct link between two routers. The point is, with CIDR, you can get exactly what you need, down to the last slice. Okay, so let's go back and solve our wasteful admin problem. This admin is giving every 25-person team a /24 network, which, as we know, has 254 addresses. The issue is glaringly obvious, right? That's over 200 wasted addresses per department. The CIDR solution is so elegant. Just give them a /27 subnet instead. This provides 30 usable addresses, which is more than enough for the 25 users, plus a little room to grow, all while saving a huge amount of precious address space.
Now, you might be thinking, okay, that's a neat bit of internet history. But the truth is, this innovation isn't just history. It's the invisible engine that keeps the entire modern internet running and allows it to keep growing today.
When you boil it down, CIDR's legacy is threefold. First, it brought incredible efficiency, stopping the massive bleeding of wasted IP addresses. Second, it gave network admins the flexibility to build networks that perfectly matched what they actually needed. And finally, and this is a big one, it allowed all those network routes to be combined, which kept the internet's master address book from getting so huge that routers would just collapse under the strain. It literally saved the internet from itself. Seriously, without the efficiency and scalability that CIDR introduced, the explosive growth of the internet we've seen would have been absolutely impossible. Every new smartphone, every smart speaker, every new gadget that comes online owes its connection, in a way, to this clever solution that let us slice the IP address pizza just right. And so this brings us to one last thought. CIDR was the ingenious fix that saved the old system IPv4 and kept the internet chugging along for decades longer than it really should have. But now, as we look to a future with not just billions, but trillions of connected devices, you have to ask the question, is this incredible patch still enough? Or is it finally time for that postcode from space IPv6 to take over for good?